Let's look at this problem. It is a geometry problem. There is a piece of rectangular paper. The dimension is given like this. The width is 20 units and the length is 25 units. Okay. Now, we place 100 disjoint unit blue squares on the table, on the paper. Okay? So what kind of unit blue square? Like this. Okay? 1 by 1 unit square. But the location orientation can be, pretty much you can do it in any way you like. Okay, 120 such squares. All right. So after that, now the question. We want to show there exists a circle of diameter 1 in the remaining white space, because a lot of places already occupied by those blue squares. So now we need to find a diameter 1 circle. We want to find the white space that is big enough for us to place this diameter 1 circle. That is the problem. Okay. Next, let's look at how to do the analysis on this problem. All right. First, let's examine the uncertainty in this problem. A lot of things are uncertain here. First, locations of 120 blue squares. It's uncertain. Can you give precise descriptions on the locations of those 120 blue squares? You cannot. So you don't know. Okay? So that's one of the reasons it is hard. Okay? Next, the shape of white space. Okay? After you remove the space occupied by those 120 blue squares, what is the shape of the remaining white space? It is very hard to describe it. Okay? Another uncertainty here. So now the issue, how do we control the uncertainty? Can we find a way? Okay, there are so many things, it's very hard to describe. But can we just create some special way that can help us control that uncertainty? So that is the main issue of this problem. Okay. All right. Now, so let's examine the freedom for this diameter 1 circle. So freedom means where can we place, do we still have some free room we can use to place this diameter 1 square? Oh, sorry, diameter 1 circle. Okay? Yeah. So let's examine gradually about the white space that we can use for this diameter 1 circle. All right. Here, in order to describe the location of this circle, the best way to do it is use its center. Okay? Center gives us the location. Yeah. Although its size also matters, because is the space big enough for this circle? The size matters. Okay? The diameter 1. Radius 1/2 also is an important factor. Yeah. But first, let's worry about the location first. Okay? Yeah. The center location. All right. Yeah. So we put the center here. Then let's consider locations of 120 blue squares. Although it's hard to describe, but we know the locations will compress the freedom of the circle. Yeah. So limit the freedom of the circle. Yeah. So we want to describe using some measure to describe the space that controlled by those 120 blue squares. Okay? All right. Now, so let's look at the center of the circle. First, we know the center cannot be too close to the edge of the rectangular paper. Yeah. So we draw a strip, okay, with width 0.5. Okay. Width 0.5 strip. Okay. So first we can say the center of the circle cannot be located inside this boundary strip. Yeah. It's very easy to see it. Okay. If you place a center there, then the circle will have one portion outside the paper. That's not allowed. Okay? Yeah. So the center must be in the inner rectangular box. Yeah. Inside the inner rectangular box. Okay? Yeah. So that is the first observation. Yeah. Next. So that's the critical step. Okay. So to solve this problem, here we need to find the most important way to handle the blue squares. Okay? Right. Answer this question. How much space can each blue square control? Okay. What do we mean control? Okay. Here, it's control. Okay. So that means the space in which the center of the circle is not allowed to be there. So that's what we mean the control. Yeah. If you place the center in that space, you violate the requirement. Okay? Yeah. So let's look at that problem. Okay. All right. Okay. So we need to determine the region that a center is not allowed. Okay. We need to, give a very good description on it. Okay? Yeah. So here I draw some, dotted lines near a blue square. So you can see the center of the circle cannot be too close to this blue square. Okay? So the distance from the center cannot be closer than 1/2 of the unit to any point of the blue square. Okay? So you cannot allow that. Okay? So here, the dotted line, we know the distance from the dotted line to the blue square, one side of the blue square is 1/2 of the unit. Okay? Yeah. So, but there are 4 corners. We need to look at the distance. Okay? So here we need to draw 4 rounded corners. Okay? Yeah. So at a corner, each corner, you will see we keep the center of the circle out of the 1/2 of unit distance away from the blue square. Okay? Yeah. So here, this dotted rounded square is the control region of one blue square. Okay? So the one you see in the figure, so that's the control region. Okay. Now we want to measure this control region. So how large, how much area does it have? Okay, all right. Okay. There are three components in this each control region. Okay, yeah. First, unit square part. Okay, the blue square. So that's 1 unit square. Okay. Then 4 rectangles. Okay, yeah. 2. Yeah. Because if we combine 2 rectangles, we get 1 unit square. Okay, yeah. It's very easy to see that. The last one, 4 corners. We put 4 corners together, we will get a diameter 1 circle. Okay? So that area is pi over 4. Okay? Pi r squared. Okay? Pi over 4. Okay? Total area of each control region, 3 plus pi over 4. Okay? Simple math. Okay? Yeah. Next, we want to look at how much is the total area of those 120 control regions. Okay. Yeah. So 120 multiplied by parenthesis 3 plus pi over 4. Okay. So we simplify it, we get 360 plus 30 pi. Okay. All right. That's the total control area of all the blue squares. Okay. Then we want to calculate how much freedom for this diameter 1 square circle. Yeah. First, we calculate the area of the interior rectangular box. So that's easy. Yeah. The length, the width, length 25 minus 1, because each boundary 1/2 of the unit. Yeah. 20 minus 1, the width. Yeah. Answer 456. Yeah. Then, now we are ready to calculate the area of the remaining white space. Inside the inner rectangular box, if we remove all the blue area, what's the remaining white space area? Okay. So we calculate this number. Subtraction 456 minus parenthesis 360 plus 30 pi. Okay. And actually that white space is greater or equal to this number. Why? Because you may have part of the blue squares may have overlap with the boundary strip. Okay? Yeah, so that could happen. Okay? So even that happens, the area of remaining white space inside the inner rectangular box is still greater than this number we have here. Okay? Yeah. All right. All right. So next, simplify. Okay. 96 minus 30 pi. Okay. We want to see, is this number greater than 0? So we still have some, small amount of space, white space. Factor 30 out. We get, in the parenthesis, 3.2 minus pi. We know it's a positive number. Okay. Pi equals 3.14 something. So definitely 3.2 is greater than the pi. Okay? Yeah, we know it's positive. Okay? So that means we can select the center of that diameter 1 circle in this small amount of space. We have room for it. Okay? Yeah. Yeah. By just simple calculation, that number is approximately 1.75. Okay? So we have plenty of space to choose. Remember here, we only need to choose the white space for that center of the diameter. Because if we find the center in that remaining white space, then based on our analysis, we take care of, the space that is occupied by this whole diameter one circle. Okay, so we won't have any overlap with any blue square with the edge of the rectangular paper. Yeah, because we all consider those factors. Okay, so in this way, you see, we solve the problem. Okay. In this way, you see, we find a location for the center of the diameter of one circle. Okay. So we find a solution.